In this video, we're going to talk about the topic of linear functions. And for some odd reason, a lot of people have problems with linear functions. If we remember that a function is basically an input map or a list of inputs that get mapped to one output, one distinct output, then we can basically start forming a hypothesis based off the characteristics of a linear function. Now, a linear function is normally given in this format to high school students starting off. They do y equals mx plus b. Okay? Now, another format that people like to use is using function notation, which is a function of x equals mx plus b. And this is the one that is most commonly used by upper level mathematics in college. It is important to note that f of x equals y. It's the same thing. They mean the same thing. Okay? A function of x is the output. Okay, so the function of x implies an output value. So it's an output or y value, however you want to think of it. So when you see f of x, just think of y. Just think of the y point in a xy coordinate. Now, it's important to note that we have several things that occur. When you have a linear function, you have some key important factors that go in determining how to graph it without drawing a list of values. M is a proportion of the change in y over the change in x. In truth, it is the difference of y2 minus y1 all divided by your x2 value, so your second point, minus the x1 value. Now, also another important key thing, b implies the point in which you cross the y-axis, the point that intersects the y-axis, the y or f of x axis. Okay, so if we've got some x-axis and we got the function of x-axis, which is the same thing as y, basically, let's say I've got a function of x equals 2 times x plus 3. Now, you can create a table of values and figure out what they're going to be. So x, f of x. Let's just do -2, -1, 0, 1, and 2. Basically, what happens is you get 2 times, and we're going to use blue, the -2 value, the x value, and I'm going to add 3. And that's going to give me some value. I do the same thing for all the others. And so as you can see here, I'm literally taking my x values and I'm just substituting them in where I see x to what y equals. So 2 times -2 is -4, -4 plus 3 is -1. 2 times -1, -2 plus 3 is 1. 2 times 0 is 0, 0 plus 3, 3. 2 times 1, 2, 2 plus 3, 5. 2 times 1, 2, or 2 times 2 is 4, 4 plus 3 is 7. Okay? So you have -2, you're going to be at -1. At -1, you're going to be at 1. At 0, you're going to be at 3. And then at 1, you're going to be at 5. And then at 2, you're going to be at 7. Now, if you draw the line, you'll see basically makes a line. Assume it's a straight line. There is something special that happens right here. And what that value is whatever you added onto x. If you look at it, this point takes on the value, whatever x is, 0, your y value is going to be 3. So whatever your sign is, okay, and we said 2x plus 3, because it's positive 3, it's going to be at positive 3 on the y-axis. So this is the basics of a linear function. Now, let's say you're just given a point and you want to find the slope between 2 points. Basically, what this does is it calculates the length of the hypotenuse between 2 points. Okay, and we'll talk about that. So let's look at the point 0, 3, and we'll look at the point -2, -1. Okay, so I'm going to use the color code values, and I'm going to restate these values. Okay, let's say I've got this point right here, and I've got this point right here. Well, this point right here is 0, 3, and this point down here is -2, -1. Basically, this is going to be my my x2, y2 point, or it's going to be point 2, and then I'm going to have point 1, which gives me my x1, y1. If I want to find the slope between those 2 points, I'm going to calculate the change in the y over the change in the run. Okay, basically it's also known as rise over run. And basically what that calculates is it calculates the length or the slope of that hypotenuse. And so if we utilize the formula, we got m equals the change in y over the change in x, which equals, and we said y2 minus y1 over x2 minus x1. And basically I'm going to plug in the values right here. So -1, because that's my point 2, minus, and I'll go back to the standard notation, and the other one was 3, over -2 for the x value, so -2, minus, and it's very important you put these in parentheses, or else you're going to mess up on your multiplicity rules, -0. And basically what this will simplify down to is -1 minus 3 is -4, -2 minus 0 is -2, and what this will reduce down to is -4 divided by -2 is 2. And basically, I'll put it in blue, it is the value right here. It's the number in front of x that tells you how you should run. So in general, if you have ax plus b, and you're given a whole value like 2x, then that tells you your slope is 2 over 1. Kind of like what we have right here. So that is basically how you can draw a linear function. And also you can find all the constituent points, which is basically, normally people want you to know how to find the slope, the place where you cross the y-axis. So I hope this helps.